As the field of anti-aging continues to mature, NAD, boosting supplements like nicotinamide riboside, NR, and nicotinamide mononucleotide, NMN, are poised to become some of the most mainstream and commercially successful interventions, promising to enhance cellular energy, promote DNA repair, and support healthier aging from the inside out. These compounds work by replenishing nicotinamide adenine dinucleotide, NAD, a coenzyme that is indispensable for mitochondrial function, metabolic regulation, and longevity-linked enzymes such as sirtuins and PARPs.
NAD
Levels decline steadily with age, and this depletion is believed to contribute to many hallmarks of aging, including reduced energy metabolism, increased DNA damage, and impaired stress resistance. The allure of restoring these systems through a daily capsule is powerful and increasingly backed by early human data. Multiple human trials have shown that oral NR supplementation can safely raise blood NAD levels, in some cases by up to 100%. These effects are consistent, well-tolerated, and sustained with continued use. NMN, while slightly less studied in clinical settings, has shown comparable promise and is now widely available in consumer markets. In animal models, NAD precursors have led to remarkable outcomes: extended lifespan, improved insulin sensitivity, enhanced cognitive function, and even reversal of some age-related physiological decline. These findings, combined with the theoretical elegance of replenishing a core metabolic molecule, have made NAD boosters one of the most widely discussed and adopted supplements in the longevity community. However, the enthusiasm comes with a necessary caveat. In humans, evidence of actual life extension or even clear health span improvement is still emerging. While raising NAD levels is undoubtedly a biological achievement, the downstream benefits may vary significantly based on individual contexts such as age, baseline NAD status, genetic background, and presence of disease. Some people may experience noticeable improvements in energy, sleep, or recovery. Others may see no tangible effects. This heterogeneity reflects a deeper truth. Supplements do not operate in a vacuum. Their efficacy is shaped by how they interact with the user's underlying biology, lifestyle, and existing cellular environment. Regulatory agencies are beginning to take note. The FDA recently took action regarding NMN's designation, signaling a move towards stricter scrutiny of these compounds, especially as they transition from supplement shelves to pharmaceutical interest. Future research will need to clarify not just safety and NAD boosting ability, but also whether long-term use translates to measurable clinical outcomes, such as lower rates of chronic disease, improved physical or cognitive performance, or biological age reduction. Well-powered, placebo-controlled trials over years rather than weeks will be essential to separating credible anti-aging potential from mere marketing. As the market expands, we can expect to see greater stratification within the NAD space. Some formulations will emphasize bioavailability, using liposomal delivery, sublingual administration, or sustained-release capsules to maximize uptake. Others may combine NAD precursors with synergistic ingredients such as resveratrol to activate sirtuins, apigenin to inhibit CD38, an NAD-consuming enzyme, or mitochondrial cofactors like PQQ and CoQ10. The future of NAD supplementation will likely look more like targeted protocols than one-size-fits-all pills. Consumers may undergo blood or saliva testing to assess NAD levels, oxidative stress, or mitochondrial function, allowing practitioners to personalize regimens in much the same way cholesterol or vitamin D are managed today. In clinical settings, NAD precursors may also be used adjunctively with physical therapy, post-surgical recovery, or neurodegenerative disease management, where the need for cellular repair and resilience is high. In these scenarios, even modest gains in energy production or inflammation control could be meaningful.
Intravenous NAD
Therapy, while still niche, may gain a stronger foothold as a rapid intervention for acute stress, fatigue, or detoxification, although its longevity effects remain speculative. The public narrative around these compounds will continue to evolve. While early adopters may swear by their results, scientists will insist, rightly, on large-scale, replicable evidence before making broad health claims. This tension between excitement and caution is a healthy sign of maturation in the field. NAD boosters are no longer fringe. They're entering the mainstream, but with that shift comes a responsibility to match bold promises with rigorous science. In the next phase of the longevity revolution, NAD, precursors will likely occupy a respected, if conditional, role, not as miracle pills but as tools, potent in the right hands, most effective when used in harmony with diet, exercise, sleep, and other foundational pillars of aging well. As clarity grows and formulations improve, these molecules may earn a permanent place in the anti-aging toolkit, not for everyone, but for those whose biology and lifestyle align with their mechanisms. And that alignment between intervention and individual is where the real future of personalized longevity lies.